Hi, everybody. So I'm Lavinia. A lot of people know me here. I know a lot of people here. And I'm just going to talk about leachate tests and applications. Simple as that. I'll get right into it. We all know what leachate is. I actually had to look it up. So Wikipedia gave me a definition. I knew what it was in my mind, but an official definition is a leachate is any liquid that, in the course of passing through matter, extracts soluble or suspended solids or any other component of the material through which it's passed. So environmentally speaking, leachate is any liquid material that drains from land or stockpiled material and contains significantly elevated concentrations of undesirable material derived from material that it has passed through. They use a lot of material in that sentence, in that phase there. So what's a leachate test? Well, it's a laboratory method designed to mimic environmental leaching events. And the goal is to obtain data relating to analyte leachability. And leachability may be used to simulate natural attenuation, evaluate the risk of contaminant leaching and reaching a groundwater or receptor, or even determine the appropriate waste disposal route. Why do we, contaminated sites professionals and under the CSR, why do we use leachate tests? Well, Glenn mentioned we're looking at adjusting P2 and providing you can use site-specific standards. You can determine a site-specific standard using method 2A and B. With the use of a ministry-approved soil leachate test, we don't have one. And I don't think anybody has ever gotten a site-specific standard approved by us using a leachate test because we don't have. Oh, there's been two. Oh, thanks. Okay. So we also realize P2 it doesn't get used that often. Glenn says twice now. I think maybe that's the only times. Those are the only times. So there's other ways that we can make that protocol a little bit more useful as well. We use leachate tests in Protocol 13, Appendix A, to determine groundwater concentration, potential groundwater concentrations. And there might be future uses for leachate tests if we come up with a ministry-approved method. One is you heard about hazardous waste is going to be decoupled with the CSR. We might be able to use a leachate test for very highly contaminated material under P12. We could use it for soil relocation and have more assurance about co-disposing large amounts of material. And we could use it for waste management at contaminated sites. So what types of leachate tests are there out there? Well, I determined that there are actually many. A lot of them, some for mining, some for sediment. It's amazing how many leachate tests there are. But the industry standard that we all know about and we all use are TCLIP, TCLP, and SPLP. And that's just a picture of the device they use to determine these leachate concentrations. You take some soil, some solution, 20 to 1. With the TCLIP, I believe it's acetic acid, but at a pH of about 4.9. And you rotate it for 24 hours, and then you filter it and analyze the filtrate. And interestingly, I learned that the TCLIP methodology is supposed to represent a 3-meter landfill depth, 100 centimeters of annual rainfall, 5% co-disposal with municipal waste, 100% rain percolation through the landfill, 1 gram per centimeter cube waste density, and 3 years of leaching. I can't imagine how this test does that, but, but that's what it's supposed to represent. So the metal contraption you see beside those jars is a zero-head extractor, and that allows you to do this leachate test for volatile organics like BTEX. The other method that many jurisdictions use, SPLP, synthetic precipitate leachate procedure, or precipitation leaching procedure. It's very similar. They use a different acid, nitric nitric or sulfuric. The pH is 5.2 if you're west of the Mississippi. And it's a 20-to-1 ratio, and particle reduced as well, same as T-clip, 18 hours of rotation, and it's supposed to simulate acid rain. So are these, when we had to study come up with a ministry-approved leachate test, we wanted to know if T-clip and SPLP are reasonable tests. And so, we started looking at what people thought about them, and they're often considered actually overly conservative. But another point is they're only single-point tests, and they're only adequate where there is a reasonable match between field and lab conditions. So, what happens if your field conditions change over time? That's a rhetorical question. Your leachate concentration is going to change as well. So George passed over to me to research it. We started with a study done by the Washington Department of Ecology. I think it was done actually in 2003. It says 2002 there. And they looked at 16 leaching methods, and they wanted to, look at the precision, and, they wanted to determine what was the best leachate test to use as well. That's where they were. And they couldn't approve of any single test. And what they recommended was an approach using a small amount of leaching tests and a hierarchy in which the type and number of tests employed is scaled to the amount of leaching information required by the user. So the Washington Department of Ecology was aware that this approach, this hierarchy approach to assessing leaching at a site was used in Europe, and that the US EPA was also looking at it. A person by the name of Cosson in 2002 and their colleagues came up with a leaching environmental assessment framework that has been endorsed by the US EPA. They call it LEAF for short. It's a tiered approach to leachate testing. And again, you use a suite of available tests, which may be used individually or integrated, to provide leaching behavior over a range of different scenarios. And consideration of waste and scenario-specific information can allow you to replace conservative assumptions, conservative concentrations, with less conservatives as you go up the hierarchy. Let's see if I have anything more to say about that. Oh. Oops. It was interesting to note that the EPA endorses this framework, but it doesn't replace T-clip. It's only for situations where T-clip is not required or it's just not appropriate, is how they're saying it. And some of the examples they gave were, it's great to use this framework for characterizing potential release from high-volume materials. It's great for using when you want to reuse material at a site. And it's also great to use this method to help make remediation decisions. So this is the hierarchy approach that the EPA is endorsing. And the first situation would be is if you have a site and you need to look at the scenario. You would look at the pH, the redox conditions, the hydrogeology, the physical parameters, and you would get an idea of where either your waste was your material was going to be, or your waste was going to be disposed of. So you would look at that. And then you would go into Tier 1 or Tier 2. So Tier 1 is a screening level assessment. So this would be the most conservative assessment. You don't have a lot of site-specific information. You would use your most aggressive test, leaching test. And you would actually use a correction factor as well. So you would get a leachate concentration, times it by correction factor, and then compare it to your groundwater standard. That's Tier 1. But if you have more information on your site and you feel that the Tier 1 is too conservative, you can go into Tier 2. And that's where you use a different leaching test, which you can compare the two tests in order to get a less conservative number. And the whole idea with the two tests is that the first test would demonstrate if all the contamination is available for dissolution. That would be your most conservative situation. And the second test would help you determine if it's equilibrium based. So they call it solubility constrained. So all your contamination cannot, or all your, the parameter does not dissolve fully into solution due to equilibrium conditions. It could precipitate out, etc. And the third tier, as they call the mass transfer rate tier, would be very complex situations. You might want to look at diffusivity as well, but generally you want to know what your leachability would be with amount of over a period of time, looking at mass flux. And that you would have other leaching methods. So, the first leaching method, and this would be the one that is in tier 1, is method 1313. These are all validated methods now, standard methods. None of these methods there's no T-clip or SPLP. I just wanted to tell you. So this is the first one. And you basically have an amount of material in a known volume of water, usually 10:1 liquid to solid ratio, buffered at different different pHs, and you shake them up for a certain amount of time, and you analyze the filtrate. And you get a curve of, and here's the example, selenium versus pH. What you can see here is how much information you get. At low pH, you get high concentrations of selenium. At neutral pH, your selenium leachate, selenium that leaches, is much lower. So that is your most aggressive test for tier 1. And that's just kind of some typical results for method 1313. You can see highly soluble materials they're not dependent on pH. Cationic species are higher at lower pHs, and amphoteric species, which I had to look up what that meant. I'm not even going to explain what that means, but it's like lead oxide and copper oxides. You can see that at low and high pH, they're dissolved into the solution. Method 1316. That's the second method in the tier 2 methodology, LEAF methodology. It's very similar. Well, it's actually different. You take a known volume of material and you shake it in flasks, but instead of being different pHs, you have different liquid to solid ratios. So from 0.5 to 10, let's say. And this method here would generate basically contaminant concentration versus liquid to solid ratios. And generally this method, if you have a lower liquid to solid ratio, you would see the highest concentrations. Of course, it makes sense. And this test helps you determine whether your leachate or your contaminant is constrained by solubility conditions or if it's all available for dissolving into solution. So that's for the tier 2. Method 1314 is another method that's recommended by the US EPA. It can be used in tier 2. I think it could be used in tier 3, although I haven't seen them state that. So what it is, it's a column test where you have a reservoir of water that gets pumped into a column, and then you measure at the end. You measure the concentration at the end, and it actually gives you the same information that method 1316 does. So I don't know why they would have included this method in their methodology, to be honest. Unless you know the rate of flow, you might be able to get some mass transfer ideas, but that's only if the rate of flow you're using is the same as what's out in the field. So, but that's another test that they use. And There's kind of what it would look like. You can imagine how expensive this would be to do. The last method is called the tank leaching test. And again, this one is more popular in Europe. I don't think I've ever seen it done here. I've seen column tests done at the university. So just so you know, they are done, especially in mining. But this one's really cool. You get it's to determine diffusion and mass flux as well. So you get a block of bedrock, let's say, and you would move it from one tank for a certain amount of time and analyze the water, and then move it to another tank and then analyze it, et cetera, et cetera. You can also do it with compacted granular material and move it from tank to tank. And you generate a plot here of, a release over time, basically release of your contaminant into solution over a period of time. This is kind of an example that was provided by the EPA in a study, a very extensive study that they did in 2014, trying to compare all these tests with other tests, but mostly compare it to field results. But this was really interesting. In pink, you could see the T-clip result. In green, you can see the SPLP result. In red, method 1313, pH dependence. And what's the other color? Or yellow? You can see it's method 1316, liquid, solid to liquid ratios, or liquid to solid ratios. I think it's kind of interesting that SPLP is better at predicting what the leachate would be at the natural pH of the material. And T-clip does over-predict. But what this tells you is that at different pHs, and not that much different in range of pHs, like between 4 and, let's say, 9, like anything below 4 and above 9, you can get quite a difference. So it also, these plots can tell you what's availability constrained and what's solubility constrained, and whether you can use the less conservative leachate concentration. So what's the recommendation we came after studying all these leaching tests? To be honest, I thought this was going to be a very easy study. I thought I was going to go in and I was going to look, everybody uses SPLP and T-clip, and that's what we were going to recommend. It's in P13, that's, it's done. But there was really a kind of a new wave that came out recently about looking at a framework for assessing leachability rather than just one test. So our recommendation to our group was basically, let's adopt these new leaching methods approved in the hierarchy approach, the LEAF approach, and look at a similar tiered approach to leachate testing, but tailor it to BC. We looked at the simplest tests, 1313 and 1316, and we're kind of like not looking at the column testing and the tank leaching methods because they're very long. Maybe just for complex sites we would do that. So we would look at methods 1313, 1316, and look at the tiers, tier 1 and tier 2 of the LEAF hierarchy, and maybe we can allow the approved professionals to validate that and not worry. We wouldn't worry about that. But if you wanted a more complex scenario, like a really heavily contaminated smelter site, let's say, you might want to use everything that's in the full hierarchy structure of LEAF, and that would have ministry oversight. So we kind of were batting around ideas, and I'm going to be a little bit repetitive, so I apologize. But so this would be kind of like an example framework, BC Leachate framework for Protocol 2 we could use. So Tier 1, if you want to get a site-specific standard, you would use the model, of course, right? That model is supposed to be the most conservative assumptions in it. You can adjust some parameters in the model, and then you can get your site-specific standards for the groundwater pathways, at least. Tier 2, you would go into, let's say that was too conservative. You would look into using method 1313 You would compare the highest concentrations with your groundwater standards. Whether we use a correction factor or not is something that, I think we need to discuss. But, and that would be similar to LEAF Tier 1. And then our Tier 3 would be you use method 1313 compared to method 1316 and see if you can use get that less conservative concentration. Tier 4, of course, would be to use all the tools available in LEAF. There's more tools in these 4 methods in LEAF. I didn't mention. There's beyond the leachate test methods, you can use equilibrium speciation modeling to help, get a better idea get a better idea of what the contaminants are doing in solution at a site. Those methods would probably require ministry oversight. I recognize that none of these methods probably have ever been used in BC. I know they haven't because I've asked. And but they have been around in Europe for some time. I think ALS in Britain, I think Mike gave me an advertisement from Britain, it was ALS, that they now have the 2 newest procedures, which was the percolation column procedure and the tank leaching one. So there you go. And their next steps would be, well, we need to develop that protocol. We need to develop our own leaching assessment that can be used in P2. And maybe it could be a separate protocol or be incorporated into P2, we don't know yet. And solicit the CSAP help, which I think Mike and the management team have already forged ahead on that. So, thank you.